Next speaker is Dr. Melanie Willis, who's with Lone Star UAS Center at Hammond CC. And what she's going to do is tell you a little bit about that program, that center, what it's doing. Maybe a little announcement about the recent chunk of change that came in. Okay.
All right.
So without
Sounds
any
good.
further ado, we'll let her get started.
Well, thank you. I'm going to be at Lone Star UAS Center, and then I'm going to show some videos because I know a lot of you already know about Lone Star. So a little bit of overview, a little bit of fun. So the Lone Star UAS Center of Excellence and Innovation, we're a research center at Texas A&M University-Corpus Christi. We are also a joint TEAS research center in College Station, so Texas A&M Engineering Experiment Station. We are also an FAA, Federal Aviation Administration designated test site. All right, I'm just going to talk a little bit about our history and then some of our flight testing infrastructure that we have, and talk a little bit about our recent research. So the United States commercial airspace system is one of the most complex and safest in the world. And this is something, as a member of the public, you just take for granted. As a consequence of that, the FAA has been very slow and deliberate in bringing drones into that airspace. So Congress became a little impatient with this progress. They wanted to open up drones for commercial uses. So in 2012, they commanded the FAA to select 6 test sites for UAS integration. So there was a national competition, and Texas A&M Corpus Christi took the lead for the state of Texas in leading a team to go forward. We were designated by the governor's office as the only team from Texas. And in December of 2013, we found out that we had been selected as one of the 6 test sites. So this is a tremendous accomplishment for our university and provides a lot of opportunities in unmanned aircraft systems. So you can see on the screen the other blue stars are the locations of our sister test sites. So as a test site, we have our first purpose with the FAA is to provide them with data from all of our flight testing. So right now they're in the process of creating rules and regulations to fly drones. An example of this is the small UAS rule that came out last August. So this was the first time that there is a regular use of drones in the airspace. Prior to that, everything was by exception. You may have heard people today talking about flying under their COA. To fly anything larger than a small UAS under the small rule or do things outside of the rule, you still have to get a waiver. So you're flying by exception. So integration process in the test site contributes to by pioneering different types of flight permissions and providing data to the FAA. So as a component of the university, we have an educational mission. We work with students, we teach classes, and then in the state of Texas, we promote economic in this new industry throughout Texas and in the coastal bend. So one of the questions we sometimes ask, why Texas? Why did they choose our test site? And one obvious answer is that just miles and miles, we have almost no commercial traffic. We also have very good weather, and we have very sparsely populated areas of the state. We also have a variety of geographies and climates, so all of these make it a very good place to test UAS. In addition to that, when you think about the industries that are going to be impacted by UAS, that have use for drones, a lot of these industries are number 1 in Texas. So for example, out of all the states, we have the most bridges. We have the most offshore oil platforms and miles of pipeline. We have 4 of the top 11 ports. So all of these are industries here in Texas, and it really makes sense to develop the methods and these aircraft right here. So our infrastructure, so this is kind of thinking about what actually is our test site. We do have some facilities to test. It's not just the flight testing facilities or the unmanned aircraft system with all of its components. It's also the team of experts, pilots, engineers, in my case, an attorney, and then our regulatory permissions to fly with the FAA. So of course, you can buy your drone on Amazon, but you can't just go out, pop it up. From the FAA perspective, they regulate it to the blade of grass. This is a really interesting thing because we've never really had aircrafts flying really close to our homes. So if you think about things like package delivery, this is a whole new paradigm. So the technology is very interesting, and that goes along with it is also interesting. Our test site is located in the Coastal Bend Business Innovation Center, which is part of Texas A&M Corpus Christi. It's in Flower Bluff, Texas. We also have range operations centers at some of our test ranges. These provide different types of equipment and connectivity to the internet and other resources. We have a mobile mission control center that provides some capabilities for testing, and that will go wherever we can pull it on our truck. Finally, we also have an electronics integration lab, and we work of integrating new payloads and testing them and doing modifications to aircrafts. And my colleague Luis Hernandez is here today. He's one of the engineers that those integration and if you'd like to talk to him about that. So our Mission Control Center, this is sort of an interesting facility, and none of the other test sites have this. It's basically a large situational awareness room, kind of like an air traffic control room. We can bring in live data, video, and telemetry from our aircraft while we're flying from almost anywhere, connected by satellite. In the future, we might be able to use this room as a remote operations center, and we could actually fly aircraft out of this room. Conceptually, they could be anywhere. So that's one of the things as we move forward with the FAA that we're trying to build up our maturity and get permission to do that. This is just to show as a FAA test site, we have a long list of COAs. We have all different kinds of permissions, not just to fly small UAS, but to fly larger UAS at higher altitudes. And we're continually expanding our airspace in that way. We have a broad area COA. We have permission to fly in Class G airspace throughout the country, and that's for small UAS. I won't talk a lot about vehicles, but we also have a fleet of vehicles. These are some examples, and also some of our partners' aircrafts. Many of them are small UAS. Also, at the university, the Arcturus RS-16, and that's a medium-sized aircraft. And a group at the university got a grant recently. It's a large, I think the takeoff weight is about 200 pounds. So at the test site, there's kind of a dichotomy of the types of things we do. What you'll hear a lot about today is data. So for a lot of people, the purpose of us is to get the data. You start with a sensor, and you heard Dr. Sterick talking about LiDAR, what your mission, the data you need. Some sensors are more or less useful, and then you can sort of approach the problem of, once you have your sensor to collect your data, which type of aircraft do you put it on? The other side of that is sort of the aeronautical avionics research, and with site we partner with the and NASA. So just to point out a few things, I think Dr. Jung mentioned this earlier. One of the key differences between a UAS or a drone and a manned aircraft is that pilot on board. And one of the key implications is your drone cannot see and avoid other aircraft like a pilot can. So even when you have a commercial jetliner, that's the last line of defense, is the pilot looking out the window. So if you have the pilot on the ground and all of the equipment, then you need a way for that drone to see and avoid objects. Because especially when you're not in commercial airspace, there are people flying small Cessna aircrafts, and they don't have to be connected to any kind of system. They don't even have to use their radio. So if you can't see them, you might hit them unless they see you and get out of your way. So we work with NASA to develop technology so that drones can see and avoid. So these are just sort of a smattering of some of our other projects, and I'll go through in the interest of time. So we did a project last year with the Department of Homeland Defense and our partner MTSI, and this was looking at using multiple small UAS and how we control and manage those UAS in low altitude airspace. We've also worked with the Texas A&M and demoed several different aircraft and sensors to help them evaluate whether this technology would be useful for them. We've been working with Texas Parks and Wildlife, and that's a shot of our lead engineer, Mo, as well as Dr. Sterrett. They ended up flying 3 aircrafts over the Redfish Bay, and the purpose of that is to evaluate whether people are following the propeller rules and staying out of the protected seagrass. So if you look at the photos, the dark grass, but those white streaks have come and damaged the seagrass. So this is actually an obligation to do these periodic surveys, something that drones for. So now I'll talk about our NASA project, and this is one of my favorite projects. We've been working with NASA for the last 3 years, and one of the projects we work on with the UTM project, or UAS traffic. So when they sort of thought about the future of UAS and the potential of having all these drones near our homes and schools and cities, what became clear, a traffic management system for commercial aircraft is an entirely different, really suited to handle this type of deconfliction. So they started a project for all of the industry partners and academic partners to work on of unmanned traffic management in low altitude airspace. So there's 4 phases, or TCLs, of the project, and we just finished up TCL2 last week. Our first mission with NASA was in 2015, and this was their first UTM mission. So we've been a part of all 4 of their UTM flights, and the key thing that we've developed is custom software that takes the real-time position from the aircraft while it's flying from the GPS and sends it over the internet to NASA. So then NASA has a 3D moving map, and it can see all of the participating aircraft where they are in real time. So they can use this to deconflict traffic and make sure that no one's going to run into each other. At least that's the basic idea of the project. So last April, all of the test sites flew multiple aircraft. So what you see on the left is the little wedges are aircraft at each test site. So we were flying all over the country, and we also had some simulated aircraft. So that was kind of fun. On the right side, we had some talented interns that developed a custom program. And this is actually really unique because it's a 3D moving map. Most moving maps are 2D. So this display is showing the aircraft that we were flying, all 4 of them, and it actually shows the angle of the aircraft. So if you're about to crash, you see it pointed down, you know, and so when you're landing and you're going, you're like, oh, okay, there we go. So I just wanted to show the video we have from our flights last week, and this goes to the see and avoid technology.
Momentous event, another one in the history of things that we're doing at Lone Star UAS Center. So for the first time ever in the national airspace, an aircraft, a small unmanned aircraft with a radar, can detect another unmanned aircraft, small unmanned aircraft, in the national airspace. And this couldn't happen without our partnerships, and it's pretty amazing. We're the first ones to be able to do that. What you're going to see today is a demonstration of a real-world scenario where we're actually taking experimental purposes and services and putting it into real action. So we're going to have a situation where we have a distress boater in the Laguna Madre. We're going to reroute aircraft out to that particular location. We're going to utilize several new and advanced sensors, such as radars on the platform. Those radars will be able to identify the aircraft that they're flying in the area. They'll also be able to identify the boat that's in distress. Once we have a fix on that location, we'll route another aircraft to that location and take pictures. This is with all Port Mansfield First Responder Group. It includes coordination with NASA, it includes coordination with the Federal Aviation Administration. the MESA D for detect and avoid radar system. And this is the first offering of a radar that's intended for use on airborne platforms. This radar can enable them to detect Cessnas. It can enable them to detect other small drones. In fact, it can even see birds and allow the platform to avoid them so as not to have an air-to-air collision.
Historically, law enforcement has been resistant to change, but with the emerging technology and how we can utilize it, it saves manpower, it reduces the risk to human life, and allows us to respond immediately to a situation and gather data. And our specific location, it ranges from search and rescue to a criminal activity response. And by using the drone technology, operations, we're able to be on station in a very quick manner, gather the intelligence so we can properly respond we need to put in place for it.
NASA's role in today's demo is providing a research platform that not only Texas but multiple can connect their system prototypes and test out their operations and different technologies that can connect into our research platform to help us understand the operational characteristics needed to safely enable large-scale UAS operations. The key is safety for autonomous flight. Flight is a safety-conscious transport. It's a safety-conscious environment. There's no such thing as a mid-air fender bender. And the FAA is charged with maintaining that safety while at the same time helping us find solutions that can carry safety but be compatible with the commercial opportunities that exist for autonomous UAS flight beyond visual line of sight.
So I wanted to show just one more thing if I can find it, to kind of give you an idea what the video looks like. All drone that was here.
6 days, our 9th anniversary of the big event.
Sorry. So the smaller drone that was going to the boat, what that kind of looks like. So just looking at the video, you see how deliberately it is able to move. So when you think about using a quadcopter versus a fixed wing, I mean, it's easy to see if you're trying to, say, for example, inspect a bridge and see what the cracks look like, this might be the type of platform you're looking at. You also heard all the noise, and there's a lot of vibration on the platform, and you saw the spinning at the propellers. So there's sort of disadvantages and advantages of using different types of platforms, and I'm sure y'all will hear a lot more about that today and this summer. So that's all I have.